When transitioning from copper water service to PVC piping leading to a water heater, it is advisable to install jumpers to the metal valves in the tank and connect them back to the copper plumbing. This recommendation stems from the potential for galvanic corrosion arising from the contact of dissimilar metals. Galvanic corrosion is an electrochemical process where one metal corrodes preferentially when it is in electrical contact with a different metal in the presence of an electrolyte such as water. In this scenario, the copper plumbing and the metal valves and the water heater, which may be made of brass or steel, constitute dissimilar metals. The PVC pipe, being a non-conductive material, introduces a break in the electrical continuity of the plumbing system. Without proper bonding, this break can exacerbate the effects of galvanic corrosion. The purpose of installing jumpers is to equalize the electrical potential between the different metallic components of the plumbing system. By providing a lower resistance path for electrical current to flow, the jumpers minimize the potential difference between the copper pipes and the metal valves, thereby reducing the driving force for galvanic corrosion. The installation process involves several key steps. Firstly, you must shut off the water supply to the water heater. This is a fundamental safety precaution to prevent water damage during the installation process. Locate the shut-off valve on the cold water supply line leading to the water heater and turn it off. Secondly, you must disconnect the PVC pipes from the metal valves and the water heater. Carefully disconnect the PVC pipes from the metal valves, using appropriate tools such as pipe wrenches or adjustable pliers. Be mindful not to damage the pipes or valves during this process. It may be necessary to use heat or penetrating oil to loosen stubborn connections. Thirdly, you must install a dielectric union between each metal valve and the PVC pipe. A dielectric union is a specialized fitting designed to electrically isolate dissimilar metals. It typically consists of two metal fittings separated by a non-conductive material, such as plastic or rubber. The dielectric union prevents the flow of electrical current between the copper pipe and the metal valve, thereby mitigating the risk of galvanic corrosion. Install a dielectric union between each metal valve and the PVC pipe, ensuring that the non-conductive barrier is properly positioned between the two metals. Fourthly, you must install a jumper wire between each metal valve and the copper plumbing. The jumper wire provides an alternative path for electrical current to flow, bypassing the PVC pipe and maintaining electrical continuity between the copper plumbing and the metal valves. The jumper wire should be made of a conductive material, such as copper, and should be sized appropriately to carry the anticipated electrical current. Connect one end of the jumper wire to the metal valve and the other end to the copper plumbing, using appropriate connectors such as clamps or screws. Ensure that the connections are tight and secure to provide a reliable electrical path. Fifthly, turn on the water supply to the water heater. Once the jumpers and dielectric unions are installed, carefully turn on the water supply to the water heater. Check for leaks at all connections and tighten as necessary. Monitor the system for any signs of corrosion or electrical activity. The jumper wire should be made of the same type of metal as the copper plumbing to minimize any potential for corrosion between the jumper wire and the copper pipe. Copper wire is a suitable choice for this purpose. The size of the jumper wire should be adequate to carry any stray electrical currents that may be present in the plumbing system. A wire gauge of 8 or 10 American wire gauge is typically sufficient for residential applications, but it is advisable to consult with a qualified electrician to determine the appropriate size for your specific situation. The dielectric union should be installed as close as possible to the point where the copper plumbing connects to the PVC pipe. This will minimize the length of the dissimilar metal connection and reduce the risk of corrosion. The dielectric union should be rated for the temperature and pressure of the water in the plumbing system. Choose dielectric unions that are compatible with the materials used in the plumbing system and that meet all applicable codes and standards. In addition to installing jumpers and dielectric unions, it is also important to ensure that the plumbing system is properly grounded. Grounding provides a path for stray electrical currents to flow to the earth, reducing the risk of electric shock and further minimizing the potential for corrosion. The plumbing system should be grounded to a suitable grounding electrode, such as a ground rod or metal water pipe that is in contact with the earth. The grounding connection should be made in accordance with all applicable codes and standards. It is important to note that the installation of jumpers and dielectric unions is not a substitute for proper plumbing practices. All plumbing work should be performed by a qualified plumber in accordance with all applicable codes and standards. The plumber should be knowledgeable about the potential for galvanic corrosion and should take appropriate measures to prevent it. Regularly inspect the plumbing system for signs of corrosion or leaks. If you notice any problems, contact a qualified plumber to have them repaired. By taking these steps, you can help to prevent corrosion and extend the life of your water heater and plumbing system. Additionally, consider the electrical bonding requirements outlined in the National Electrical Code, NEC, specifically Section 250.104. This section addresses bonding of metal water piping systems and other metal piping that may become energized. Compliance with 250.104 is essential for ensuring electrical safety and minimizing the risk of electrical shock. If the metal water piping system is likely to become energized, it must be bonded to the grounding electrode system. This bonding connection must be made in accordance with the requirements of 250.50. The bonding conductor must be sized in accordance with 250.66. based on the size of the service entrance conductors. In cases where the metal water piping system is not likely to become energized, it is still recommended to bond it to the grounding electrode system. This bonding connection provides an additional level of safety and helps to prevent the buildup of static electricity. The bonding conductor for non-energized metal water piping systems must be sized in accordance with 250.104. Metal gas piping systems must also be bonded to the grounding electrode system in accordance with 250.104. B. The bonding conductor must be sized in accordance with 250.66, based on the size of the service entrance conductors. Other metal piping systems, such as those used for steam, compressed air, or other non-flammable gases, may also need to be bonded to the grounding electrode system, depending on the specific circumstances. Consult with a qualified electrician to determine the appropriate bonding requirements for your specific situation. Furthermore, when dealing with water heaters, it's crucial to understand the function and importance of dielectric nipples, which are similar to dielectric unions but specifically designed for water heater connections. These nipples incorporate a non-conductive sleeve to isolate the steel tank of the water heater from the copper plumbing. This isolation is vital in preventing galvanic corrosion that can occur due to the electrochemical reaction between these dissimilar metals in the presence of water and electrolyte. Dielectric nipples help extend the life of the water heater by preventing premature tank failure due to corrosion. They are generally required by plumbing codes and are an essential component in water heater installations. When installing a water heater, ensure that dielectric nipples are properly installed on both the hot and cold water connections. These nipples typically have a plastic lining inside the metal fitting to create the necessary electrical isolation. It is important to avoid damaging this plastic lining during installation, as any damage can compromise the dielectric protection. In addition to dielectric fittings and bonding jumpers, consider the quality of the water itself. Water chemistry can significantly influence the rate of corrosion. Factors such as pH, alkalinity, and the presence of dissolved salts can affect the corrosivity of water. If you have concerns about your water quality, consider having it tested by a qualified water treatment professional. Depending on the results of the water test, you may need to install a water softener or other water treatment equipment to reduce the corrosivity of the water. Maintaining proper water chemistry can further extend the life of your plumbing system and water heater. Also remember to consider the type of metal used for the valves on the water heater. If the valves are made of brass, which contains zinc, they are more susceptible to dezinsification. Dezinsification is a form of corrosion in which zinc is selectively removed from the brass alloy, leaving behind a porous and weakened structure. This can lead to valve failure and leaks. To mitigate the risk of dezinsification, consider using valves made of a more corrosion-resistant material, such as stainless steel or bronze. These materials are less susceptible to dezinsification and will provide a longer service life. When selecting valves for your water heater, be sure to choose ones that are compatible with the materials used in the plumbing system and that meet all applicable codes and standards. A licensed plumber can provide guidance on selecting the appropriate valves for your specific application. Regular inspections are essential for identifying potential problems before they become major issues. Inspect your plumbing system and water heater regularly for signs of corrosion, leaks, or other damage. Pay particular attention to connections between dissimilar metals such as copper and steel. Look for signs of discoloration, pitting, or scaling. If you notice any problems, contact a qualified plumber to have them repaired promptly. Early detection and repair of plumbing problems can prevent costly damage and extend the life of your plumbing system. Keep a record of all plumbing repairs and maintenance. This record will be helpful for future reference and can assist in identifying trends or recurring problems. The record should include the date of the repair, the nature of the problem, the parts replaced, and the name of the plumber who performed the work. In addition to these preventive measures, it is also important to be aware of the potential hazards associated with working on plumbing systems. Always shut off the water supply before attempting any plumbing repairs. Wear appropriate personal protective equipment, such as gloves and eye protection. Be careful when working with tools and avoid damaging pipes or fittings. If you are not comfortable performing plumbing repairs yourself, contact a qualified plumber to do the work. Working on plumbing systems can be dangerous if not done properly. It is always best to err on the side of caution and seek professional assistance when needed. Lastly, consider the impact of water heater location on potential corrosion issues. If the water heater is located in a damp or humid environment, the risk of corrosion is increased. Moisture can accelerate the rate of corrosion and shorten the life of the water heater. If possible, locate the water heater in a dry and well-ventilated area. If the water heater is located in a damp environment, consider installing a dehumidifier to reduce the humidity level. Proper ventilation can also help to prevent the buildup of moisture. Furthermore, consider the use of corrosion inhibitors. Corrosion inhibitors are chemicals that can be added to the water to reduce its corrosivity. These inhibitors work by forming a protective layer on the surface of the metal, preventing corrosion from occurring. There are various types of corrosion inhibitors available, each designed for specific applications. Consult with a water treatment professional to determine the appropriate corrosion inhibitor for your specific water chemistry and plumbing system. In addition to chemical inhibitors, consider the use of sacrificial anodes. Sacrificial anodes are made of a metal that is more electrochemically active than the metal being protected. The anode corrodes preferentially, protecting the other metal from corrosion. Sacrificial anodes are commonly used in water heaters to protect the steel tank from corrosion. The anode is typically made of magnesium or aluminum and is located inside the tank. As the anode corrodes, it releases ions that react with the water, forming a protective layer on the tank surface. The anode must be replaced periodically, as it will eventually be consumed by the corrosion process. Check the anode regularly and replace it as needed to ensure continued corrosion protection. By implementing these strategies, you can significantly reduce the risk of corrosion in your plumbing system and extend the life of your water heater. Regular maintenance, proper installation techniques, and attention to water quality are all essential for preventing corrosion and ensuring the long-term performance of your plumbing system.